We have already discussed that the commercial alcohol is made unfit for drinking by mixing in it some copper sulfate or methanol, which is known as denaturation of alcohol. But do you know if a person by mistake drink ethanol mixed with methanol may cause blindness and death, as methanol is oxidized first to methanol and then to methanoic acid. A methanol poison patient is treated by giving intravenous infusions of diluted ethanol. In this video, we will discuss such chemical properties of alcohols. We have already discussed about reaction involving cleavage of OH bond. Here, we will discuss reactions involving cleavage of carbon-oxygen bond, which happens only in alcohols, and phenols show this type of reaction only with zinc. Alcohols react with hydrogen halides to form alkyl halides. Alcohols are also converted to alkyl bromides by reaction with phosphorus trihalide. The difference in reactivity of three classes of alcohols with Lucas reagent distinguishes them from one another. Now, what is Lucas reagent? Well, it is solution of anhydrous zinc chloride in concentrated hydrochloric acid. Alcohols are soluble in Lucas reagent. In case of tertiary alcohols, turbidity is produced immediately. In secondary alcohol, it appears slowly, whereas primary alcohols do not produce turbidity at room temperature. Alcohol also undergoes dehydration and converted to alkene on treating with a protic acid, example concentrated H2SO4 or H3PO4. Ethanol undergoes dehydration by heating it with concentrated H2SO4 at 443 Kelvin. Whereas secondary and tertiary alcohols are dehydrated under milder conditions. Therefore, tertiary carbocations are more stable and are the easiest to dehydrate, followed by secondary and primary alcohols. The mechanism that happens during the dehydration of alcohol have three steps. First, the formation of protonated alcohol takes place. Then, in the second step, which is the slowest step, or we can say the rate determining step, formation of carbocations take place. The acid used in step 1 is released in step 3. To drive equilibrium to the right, ethene is removed as it is formed. In case of oxidation of alcohol, the formation of a carbon-oxygen double bond with cleavage of an oxygen-hydrogen and carbon-hydrogen single bonds take place. These are also known as dehydrogenation reactions, as these involve loss of dihydrogen from an alcohol molecule. Here, depending on the oxidizing agent used, a primary alcohol is oxidized to an aldehyde, which in turn is oxidized to a carboxylic acid. Primary alcohol with chromium trioxide in anhydrous medium gives aldehyde, but for the better yield, pyridinium chlorochromate, which is a complex of chromium trioxide with pyridine and HCl, is used. But in the case of secondary alcohols, it oxidizes to ketones in the presence of chromic anhydride. Whereas tertiary alcohols do not undergo oxidation reaction. Also, when the vapor of a primary or a secondary alcohol are passed over heated copper at 573 Kelvin, dehydrogenation takes place and an aldehyde or a ketone is formed while tertiary alcohols undergo dehydration. Do you know, in the case of phenols, the OH group attached to the benzene ring activates it towards electrophilic substitution reaction? Well, we will discuss this in detail in our next video. Now, let us summarize what we have learnt.
Manorama Horizon. Learning made simple.